Questions about that? Okay, the next thing we're going to talk about is section 5.3. This is an introduction. I know it's the one before this, before we just learned. This is an introduction to polynomials. In college algebra, did you take your test yesterday or do you have it today? I'm getting mine today. So you either probably took it yesterday or today. There may be a few of you taking it on Monday or Tuesday, but first exam is taken or about to be taken, right? After the exam number 1, you start talking about quadratics, which we spent a lot of time on so far. We've been talking about solving quadratics. You're going to learn how to graph quadratics and do all kinds of stuff with quadratics. You're going to spend a day or two on that. And then the next thing you're going to learn about is polynomials. Polynomials is kind of a intense topic. There's like a lot of parts to it. And so I want to get you started now so that like you at least have a little bit of knowledge when you're going into it, so that it's not like, you know, 50 minutes of brand new information. Maybe it'll only be like 35 minutes of brand new information, because sometimes it's kind of hard to take in all of it. So that's the point of going over this right now, is to introduce you to some of this stuff so that when your teacher's talking about it, you at least know at least some of the terms that she's talking about, and it's not all like brand new information. Okay, so polynomials, this is one of my favorite things to do or to teach. I love talking about polynomials. A polynomial is an equation that just has a variable and an exponent in it. Okay, so polynomial is just an equation with variables with positive whole number exponents. So that's the first thing you're going to talk about, is what a polynomial actually is. It's just a random equation with positive whole number exponents. So an example of a polynomial would be x to the third plus 2x minus 5. Trying to decide if I want to say equals y or equals 0. Let's say equals y. Y equals that. Y equals x squared plus 2x plus 5. Do we have variables in there? Do your variables have exponents that are positive whole numbers? Yes. Another example would be x squared minus 2x plus 5. It has variables. Are your exponents positive whole numbers? Yes. That specifically is what kind of function? A quadratic function, right? Because the highest exponent is 2. We're going to talk about that a little bit more in just a minute. So quadratics are actually considered a polynomial. It's considered a special type of polynomial because it's like, technically these exponents could be any number. This could be x to the 5th, this could be x to the 10th, this could be x to the 100th power, right? So like I have all these different types of equations that fit in polynomials, and the rules all apply, but x squared ones happen really, really often. So we learn those separately because we can do extra things with with quadratic functions, but they still fall in a polynomial. Like they fall under the umbrella of the name of a polynomial function. So an example of what's not a polynomial is if I had y equals 2x to the negative third power plus 5x. Why is that not a polynomial? Because it has a negative exponent. Okay, another example of something that's not a polynomial is if I had y equals 2x to the 1/2 power plus 5x. Yeah, the problem there is that's a fraction. It's not a whole number. Okay, one other way you see the negative one, next week we're learning exponent rules. So if you don't know this as of now, don't worry about it. We're going to learn it next week. But another way you can see negative exponents is on bottom of a fraction. So if I had y equals 2 over x to the third power, that's the same thing as 2x to the negative third power. If you don't know that now, it's fine. You'll learn it next week. So just a heads up, a negative exponent is also on bottom of a fraction. So none of these will have any x's on bottom at all. Okay, so that is what a polynomial is. Polynomial equations. If I had the equation y equals x to the third minus 2x squared plus 5x minus 7. Okay, first of all, the word terms. What's a term? First of all, how many terms does this equation have on the right-hand side of this equation? 4. Most people see what a term is. Terms are just separated by plus and minus signs, okay? So they're just separated, say again? No, sorry. Separated by plus or minus signs. So x cubed is one term. Negative 2x squared is one term. 5x is one term. 7 is one term. You could have like a list of 15 variables, and as long as they're all multiplied together, that's one term. It's pluses and minuses that separate terms. Okay, so on this equation, how many terms are on the right-hand side of the equation? We said there's 1, 2, 3, 4 terms. So there's 4 terms on the right-hand side. On the left-hand side, how many terms are there? 1 term, because we just have a y. Okay, the next vocabulary word, essentially this is a lot of vocabulary is what this lesson's all about, is a coefficient. What is a coefficient? It's the number in front of an x. Okay, so a coefficient is just the number in front of an x. These are probably all like words you've heard over and over. So it's just the number in front of x squared, or a number in front of an x. So what's the coefficient for x cubed? 1. What's the coefficient for x squared? Negative 2. What's the coefficient for 5? Nope, I already told you 5. For x, it's 5, and then that doesn't have a coefficient because it's not an x. That has a different name. We'll talk about it in a second. Okay, so coefficient is just a number in front of an x. So, for example, like for negative 2x squared, the coefficient is negative 2, right? For x to the third, the coefficient is 1. And in a second, we're going to start talking about leading coefficient. So the whole reason why I'm going over this is because in your college algebra class, they're just going to start talking about the leading coefficient, and you need to know what a coefficient is. Okay, the other thing with polynomials, usually they're written in descending order. So descending order, descending means going down, right? So we write them in order of your exponents going down. Okay, so in order of your exponents from highest to lowest. Okay, so look at this problem we've been working with. Y equals x cubed plus 2x squared plus 5x plus 7. Is this in descending order? Yes. What's the exponent for the x to the third power? 3. What's the exponent for x squared? 2. What's the exponent for 5x? 1. And this number doesn't have an exponent. Technically, again, we have to learn exponent rules. We'll learn it next week. Technically, you could write this as x to the 0 power if you wanted to, and that would really be in order 3, 2, 1, 0, right? So that's descending order. So let me give you a problem and you put it in descending order. So if I had y equals 5 minus x to the 4th power plus 2x to the 5th plus x to the 3rd. Let's put that in descending order. Okay, so what's the highest exponent here?
5.
The 5. So it's 2x to the 5th comes first. What's going to be next? Negative x to the 4th. What's next? Plus x to the 3rd. And then plus 5. That's descending order. Because my exponents are 5, 4, 3, and then that doesn't have an exponent. What's the name of this term that doesn't have an exponent? You know? It's called a constant. Because it doesn't have a variable on it, it's not changing, it's always just the number 5. It's constantly the number 5. You can't make it 4, you can't make it 6. Okay, so one more vocabulary word, and then I'm going to show you the reason why we're going over all these words. One other word is the degree of an equation. This is a very important topic. Okay, so the degree of a term is a little bit different than the degree of an equation. I almost don't even like to teach the degree of a term because then people start doing it as the equation, they get it mixed up, but your college algebra teacher is probably going to teach you both. So let's go over the difference between the two. So the degree of a term. So what's a term? One thing, right? No plus or minus signs. It might have 15 letters in it, but it's just one thing because it doesn't have a plus or minus sign separating it. So for the degree of the term, you add up all your exponents for your variables. So for example, if I was just had the term 2x to the 5th power, what exponents do I have there? Just a 5. So I don't even have anything to add up. The degree of that is just 5. What about if it was 2x to the 5th y squared? You add the 5 and the 2. So the degree of this would be 7. Does that make sense? What about if it was 3xyz to the 3rd? So what's the exponent for x? A 1. What's the exponent for y? A 1. What's 1 plus 1 plus 3? 5. Okay, so the degree for that one is 5. This is the part I wouldn't even want to teach you, but your college algebra teacher is probably going to go over this, and there is a part to it where it shows up. But in most cases, when we talk about degree, we specifically want to know the degree of an equation because that tells us information. Okay, so the degree of an equation, you don't add up all your exponents. It's literally just the highest exponent in your equation, or the highest exponent term. How about that? Okay, so for example, if I had my problem I've been working with, x to the 3rd minus 2x squared plus 5x plus, I'm sorry, it was minus 7. Technically, the way you're supposed to do this is you're supposed to find the degree of every single term here, and then you pick the one that's the highest. What's the degree of this first term right here, x to the 3rd? 3. What's the degree of this term, negative 2x squared? 2. What's the degree of 5x? 1. What's the degree of this one? 0. So which one's the highest? 3. X to the 3rd. So your degree is 3. Okay. So in most cases, the degree of an equation is just literally the exponent of the first term, right? If it's in descending order, it's your highest exponent. This 95% of the time is what you're going to be doing. Let's do one more like that. Let me make it not in descending order, so you have to work a little bit harder for it. What about if I had 5x minus 2 plus x to the 3rd minus 4x to the 5th? What's the degree of that equation? Yeah, 5, because the exponent for 5x is just a 1. For 2 is 0. For x to the 3rd is 3. For 4x to the 5th, it's 5. If you ended up with some weird equation, which when you're doing polynomials, you're not going to, but let's pretend like you had some weird equation that was 5x squared y plus 2xy squared plus 7x squared y squared. I mean, that's super weird and super difficult. This is the situation where you need to know the whole idea of the degree of a term to find the degree of the whole equation. Let's start on this last one. What's the degree of this term right here? Squared plus squared, 2 plus 2 is 4. What's the degree of this middle term? 3, because that x has a 1 on it. 2 plus 1 is 3. What's the degree of the first term? 3. So what's the degree of this equation? 4. So that's a situation where you need to know how to add it up, but this is not a polynomial, okay? So you're not going to be seeing these. Okay, so what's the whole point of all these words? The degree and the leading coefficient help you graph your polynomial. That's our whole goal for these problems, is to solve polynomials and to graph polynomials for like next week in college algebra. So the degree tells you a couple of things. The degree of your polynomial tells us 2 different things. One thing it tells us is how many answers we have. Actually, it tells us 3 things. It tells us how many answers we have. So if your degree is 3, how many answers do you have? 3. If your degree is 4, 4 answers. Degree is 5, 5 answers. And this should kind of make sense because this week, like on Wednesday, when we were doing x squared plus 2x plus 5, how many answers did that have? 2 answers every time, right? Because it's quadratic, and all of our problems had 2 answers. What's the degree of a quadratic? 2, right? So the degree is 2, so we have 2 answers. The number of answers you have is your degree of your equation. Questions about that? So I said it told you 3 things. One thing it tells you is how many answers we have. The second thing it tells us is if our function is an odd function or if it's an even function. If my degree is odd, my function is odd. If my degree is even, my function is even. Okay? So if your degree is odd, it's an odd function. And this is a little bit different than the whole idea of like odd and even functions, like plugging in negative x, working it out. So if you haven't taken your college algebra test, like you're not using this on your college algebra test, okay? Don't get confused with that. If your degree is even, then it's an even function. And this is specifically talking about in behavior. And we'll talk about that in just a second. Okay, so that told you, it tells us 3 things. The first thing it tells us how many answers we have. The second thing is it tells us is if it's odd or even. The third thing the degree tells us is it tells us the maximum number of terms. This is the third thing. It tells us the maximum number of terms. Okay, and the maximum number of terms is not the same number as the degree. It's degree minus 1. Okay, so max number of terms is, goodness, that's messy, is the degree minus 1. Okay, so maximum means that's the most it can have. It's not always the number it's going to have, but you can't have any more than this number. Okay, and so for example, let's talk about a quadratic. X squared plus 2x plus 5. What is the degree of that function? Yeah, the degree here is 2. So it has 2 answers. Is that an even function or an odd function? Even function. And how many turns does it have? The maximum number of turns is degree minus 1. So 2 minus 1 is 1. That should kind of make sense. What does the graph of a quadratic look like? Do you remember? You technically haven't learned it yet because we haven't gone over in this class, and you'll learn it next week in college algebra. It's a U-shaped graph. Has a special name. Parabola. Okay, so it's some kind of parabola somewhere. This is not the graph of that equation I just wrote. It's just some random graph I just drew on there. The number of turns it has. Where does it turn at? Here at the bottom. It was going down and now it turned and it's going to go back up now. So that's my turning point right there. Okay, so do you see why a quadratic will have a maximum of one term? Because it's always going to be a U-shaped graph and it's always only going to have one turn on it. Does that make sense? Okay, so let's do like a bigger one. If I had y equals x to the fifth plus 2x to the third minus 5x squared plus 7. What's the degree of that function? The degree is 5. Is this an odd function or an even function? I didn't write that on the last one. I'm gonna go ahead and write it because I'm gonna talk about that as soon as we're done with this problem. Even function, this one's an odd function because 5 is an odd number, right? And what's the maximum number of turns here? 5 minus 1. What's 5 minus 1? 4. So at most it turns 4 times. So this is like a loop-de-loo graph basically. Let me actually look and see what this graph looks like. I just made it up off the top of my head, so I have no idea. Ouch. So if you look at this graph on a calculator, it is x to the fifth plus 2x to the third. Nope. 5x to, I'm sorry, x to the fifth. Oh, goodness. I'm having a hard time, sorry. Plus 2x to the third minus 5 plus 7. Okay. Okay, so this graph looks like this. That's not a very good picture of it, but essentially, how many turning points does this graph have? It's going up, it turns right here to go down, it turns again to go back up. So how many turning points does this have? 2. It doesn't have to have the 4. It's saying it cannot have more than 4. You could not have 5 turning points on this graph. If you graphed it and you had 5 turning points, you either typed it in wrong or you did something wrong on your degree math there. Does that make sense? Okay, the last thing I want to talk about is even and odd. I wish we had a little bit more time for this. I probably should have spent more time on this part. Even functions talks about, or the idea of even and odd functions talks about the end behavior. And end behavior is your arrows at the end. Look at these 2 arrows. How would you describe those 2 arrows? They're both going up, right? I think the way the book describes it is it rises to the left and rises to the right. How would you describe these 2 arrows? This one rises on this side, right? How would you describe this one? Goes down, decreases, falls. I think it says falls. So this one's described as falls to the left, rises to the right. Notice these 2 are together. Even functions, your arrows go together. They're either both going to go up or they're both going to go down. Odd functions, your arrows go opposite directions. One's going to fall and one's going to rise, or this one's going to rise over here and this one's going to fall over here. Okay. Okay, so that was an introduction. This is probably going to be the first 5 minutes of your lesson on polynomials, 5, maybe 10 minutes of your lesson on polynomials in college algebra. So hopefully that helps get you a head start on it. And if we need more help on this whole end behavior thing, we can go over that probably next week sometime. So make sure you're working on your homework. Any homework that you have due on Math Excel, work on that. And I will see y'all on Monday.
she did that. She didn't do it.